presentation is Recovery Modeling for Anthropogenic Impacts on Coral Reefs. Dr. Joe Keel usually comes to these things so he can answer questions about the modeling, because basically I'm just the grad student who processes the images and he's more into the modeling part, but unfortunately he's off-site so he can't be here. So if you have a question concerning the modeling, let me know. I'll take your information down, write your question down, and get the answer back to you. Okay? All right, so the scope of our work is basically to use the archived crayon photoquadrant images to generate coral demographic and size frequency data to develop planned coral reef recovery models based on NOAA's Center for Coastal Fisheries and Habitat Research Recovery Model. They developed a nice model for the Florida Keys. And basically the demographic data that we're gathering is recruitment, which is the number of new colonies that settle in an area, the growth measured as an increase in area, mortality either partial or complete, measured by a decrease in area, fission, where a colony divides into two or more colonies, or fusion, where two or more colonies fuse together. Okay, to give you an idea of what we can gather from these images, and this looks terrible here. But this is over time. So starting in 1999, this is 2000, 2001, 2002. And you can see some of the colonies changing. 2004, and finally 2005. So there is a difference from the initial images. Now, to give you an idea of what we can pick out, here's 1999, and focus on these three areas that I have. Here's a little Horanis lobata, here's a little barren spot, and here's a small Montipora capitata. Okay, in 2002, we notice we have two coral recruits that have come in here. This Montipora capitata, but there's a fishing event that's taking place. 2001, the colony that looked like this before is now like this, and so it's actually had a fusion event. Our recruits are a little larger, and by 2002, our little recruits there and our lobata that was here have died, so that's mortality. And then our Montipora capitata over here in this corner is now fused again, so that's a secondary fusion event. And there's a whole body of literature about histoincompatibility in corals, and so the fact that they are able to fuse together indicates that they're genetically identical. So this could have actually been one large coral colony before, something happened, a partial mortality event, it left little fragments behind, and now as they're growing, they're fusing back together. Okay, the rationale for this research is for two perspectives. One is the ecological, developing information on in situ coral demographics and population dynamics. And this demographic data may also be useful for climate change models. But there's also the management perspective, where we're developing a realistic recovery time model needed to assess damage claims for reef injuries due to anthropogenic disturbances, like sediment spills, dredge and fill operations, ship groundings, etc., and to assess mitigation costs, benefits, or efforts. Okay? The methods are basically using the archived photoquadrant images, a computer, and image processing analysis software. Our initial protocol called for SigmaScan, but we decided to switch to ImageJ. We did a number of comparisons to make sure that the measurements we're getting are the same. And ImageJ is actually a freely downloadable software from NIH. And basically, it's just user-friendliness is the reason we switched. To give you an idea of what an image looks like processed with SigmaScan. Once you take the measurement, the images are overlaid with this red overlay, so you can't really see what's underneath it. And if you wanted to go back and check to make sure the image is measured precisely, it's very difficult. But with ImageJ, when you take the measurement, it's outlined, and you can see that every coral is outlined in pink. So when another person goes back to check the data, it's very easy to identify the species of coral, to see that the measurements were precise, so forth. And there's also some other aspects. Once the measurement is collected in SigmaScan, you can't go back and edit it. You have to restart all over. Now that's fine for a small coral, but when you have something very complex, and even worse than this, it takes you hours, so starting all over is very difficult. But in ImageJ, you can just go back and edit the points. The other aspect is what's called a ROI file, which stands for Region of Interest. So all the traces can be saved in a ROI file, and we can go back and edit it, but we can also use it for subsequent images. So this is 1999. In 2000, I would import the raw image. It helps me to identify the coral the year afterwards, and I just go back and edit the points, and then save the file and take a new measurement. So it saves a lot of time in terms of processing the images. Okay, so basically for my work, I've been focusing on 5 sites: North Honolulu, Lapahoihoi, Ka'apuna, Pukekea, and Hanalei. And that's what I hope to finish up very shortly. Also, Eric Brown has processed all the Maui and Molokai sites from 1989 to 2002. So we'll have quite a large body of data to go into the recovery model. The expected outcome of this project is a greater understanding of in situ coral demographics and population structures for Hawaiian corals from a diverse range of habitats throughout the main Hawaiian Islands. Also to develop an extensive database on recruitment, growth, and mortality rates from the archive plant photo projects, and development of a realistic coral reef recovery model to facilitate management decisions and assess damage claims for anthropogenic injuries to coral reefs. So that's it. Any questions?